Then for case 2, it's called a real double root. That's if a squared minus 4b equals what? 0. Then the general equation is going to be y equals what? C1 plus C2 x e raised to gamma x. So when the value is real and double roots, if you find the value of gamma and you go, let's say gamma equals, let's say um 3 1 gamma 1 equals to 3, gamma 2 equals to 3, then because they are the same, you instead of you writing it in this form, then you need to put x in front of this. It's just like you put in x in front of this and you just put your gamma 1 as 3 and 3. Then you have x in front of this. So that's when you have a real double root. And for the case 3 now, we call this a complex root or complex conjugate root. Yeah, conjugate root. That happens when a squared minus 4b is lesser than 0. For this, you probably get your gamma to be something like this, plus or minus. So this is like the imaginary part of the answer. This is the real, this is the imaginary. So therefore, if you want to find a general solution, y equals what? E raised power minus a over 2x c1, let's say cos wx plus c2 sine wx. It doesn't matter how you write it. You can write sine first, you can then write cos later. It doesn't matter how you write this. And this is the real value, x. It's just like you saying y equals what? A raised power, the real value when you solve it, then c1 cos wx. And so this is the imaginary. Then it's so you repeat the imaginary imaginary part, and you have this as the real. Yeah. So that's what we're talking about. So whenever you solve a problem and you're able to get your answer in form of this, when you probably use a calculator in solving for the quadratic equation, and you're able to get something like this value, the imaginary side, will be your R, and the real, sorry, this is the real side. The real side will be this R, and your imaginary side, which is a W, will come to the cosine and sine side. That's the imaginary part. And yes, that's all for the explanation. And the next video will be solving questions that has to do with homogeneous linear ODE with constant coefficients. I hope you enjoyed the video. If you enjoyed the video, like, and subscribe to our channel. Thank you very much.